So in this short video, I'm just going to discuss directional hypotheses and one-tailed hypothesis tests. Now we're going to use the same example we used for our two-tailed hypothesis test. And again, we're still talking about a t-test for independent measures. So remember, when we're doing a t-test for independent measures, we have our population 1 and our population 2 mean. And this would be the individuals that go through specific training, and this would be the individuals who go to ordinary training. And after that training, we get a score for them to see how well they're going to be able to hold that job. Now, in a one-tailed test, we want to say that the individuals who went through the specific training are going to have higher scores. They're going to be more likely to be able to hold that job. They're going to have better new job skills. So, for our alternative hypothesis, we want to say that the specific training program, population 1, is going to have a significantly greater mean than the ordinary training program. And we also want to say that our alternative hypothesis would be that those that go through the specific training are going to have a mean that's equal to or less than those that go through the ordinary training. We also have a different alpha level. So our alpha level is still 0.05, but now, and we still have the same degrees of freedom, but if you go to that table and you look at degrees of freedom for 12 with 0.05 in just one tail, you're going to see that that critical T is now 1.782. Step 1 to step 2. Step 3, our calculated T isn't any different than in the previous video. So I'm just going to give you that value here, 2.722. So then when we make a decision, we compare these two values. This calculated T is much bigger than our critical T, so we reject the hypothesis. So the only thing that's really different is hypothesis writing, finding that critical T value.